First of all, uh, for for us who joined yesterday, we had a very fruitful session with Daniel Nderitu, who took us through the introduction to Stata. We had a chance to see how the interface looks like and some of the basic commands we can do as a startup for the software. And we had a chance to start also data cleaning, which is a very key process in data management and finally analysis. So that is about yesterday. And today, um, we have a few objectives to achieve, but most of our interaction today will be practical. So I hope everyone has access to the data sets that were shared and everyone has access to Stata. So today, all of us are going to practice with the data. So if there is any challenge with access to the data set and there's any challenge to access to Stata software, you can let us know. Do we have anyone who can still not access the data set?
Think they have.
Okay. So then, all right. So if everyone is comfortable with the data set, so then today's presentation will be very brief, and then we'll just move directly to the practical bit. So can someone confirm you can see my screen, please?
Yes, it's okay then.
Okay. So as I've mentioned, we'll just do a bit of review from what Daniel Maina mentioned yesterday on data cleaning, which we know is a very important process in data management and analysis. We are going to visit the software to work on some few descriptive analysis and know why are we doing the descriptive analysis. And then finally, we are going to handle some bivariate and multivariate analysis at the end. So I just have a reflection on why the data cleaning is important. And so I have a few notes here. Data cleaning is important because we want accurate data. We want data that is valid, and we want data that is reliable so that if you are sharing your findings from your data, you are comfortable that you are sharing results from a reliable data set so that someone does not question you like the structure of your data set. Someone does not question the reliability of your data set. So that is why it is important to ensure that the data that is finally going to be analyzed is reliable, is accurate, and it is valid. So I'll stress on validity. So on validity, for example, if you have a variable like age, and maybe you're interviewing university students and you expect their ranges to be 18 and 30 years, and you see some values like 12, 11, like just values below 18 and values above 30 that are so extreme, we know the repercussions of that. So values that are so extreme can introduce bias into our data set. And we could be seeing results in our data set, thinking that the data set is correct, but it is because of such values that have introduced bias in our data. So this is just a recap of why data cleaning is important. And if someone has an addition to why data cleaning is important, you can add. Do we have anyone who has another reason why data cleaning is important? Okay. So you can even drop in the chat box if you have any other reasons why you think we really need to do the data cleaning. So these are not all the steps for data cleaning, but I just have a short presentation on the steps. So when you collect your data set, normally or usually we have a variable that uniquely identifies all your instances or all your respondents. For example, if you're doing a household survey, you're going to have a household ID. If you are doing a participant survey, you are going to have participants ID, some ID that uniquely identifies your respondents. And it is human error or sometimes that you may have the people who are helping you collect the data or yourself, you may have that ID duplicated. So like you have used one ID to interview two respondents, or the observations are the same for two different IDs. So that can be classified as duplicates. So in the first step, you need to check that your data set is uniquely identifying. That is to mean that all the variable or your uniquely identifying variable does not have any duplicates. And then using the do file that Dan introduced us to yesterday, you want to ensure that your data is readable to yourself and to any third party. How do you do that? You ensure that all your variables are labeled and all the variable values are also labeled so that someone is, when he looks at the data set and sees question 1, and then they can see a label to it and say, question 1 was about household income, or question 1 was about gender, or was about schooling, or something like that. So you ensure that your variables are labeled and all the variable values are also labeled. And then we had a discussion yesterday on how to handle missing data or invalid data. So just to ensure that the implausible values, the values you think are not suitable for the data set, are correctly handled. And you determine how to handle your data, whether you record them to missing or whether you use imputation methods that we spoke about yesterday. So those are some of the steps to cleaning your data set. And the other step that I have not mentioned here is recording your variables that Daniel also mentioned yesterday. We were taken through that so that you ensure that your variables are ready for analysis. So for example, the data set that we were shown yesterday, that was Shamiri, all the variables were string variables. So you want to ensure that you record the variables to numerical variables so that they are suitable for your analysis. Now, do you have any questions up to there before we go to the analysis? Okay, if there's no questions, we'll continue. So I'll speak about descriptive analysis, and as the word sounds, descriptive analysis is just to describe your data. How does your data look like? What is the variability in your data? What are the central tendency means in your data? What is the distribution of your data? So descriptive analysis is all about describing your data set, how it looks like. And we have a few variables to look at when we talk about descriptive analysis. We have frequencies, we have means, we have medians, mode, range, variance. So such kind of things tell us more about our data. It's more about exploring that data set. So we are going to see this live in Stata in a bit. And then once we do descriptive analysis, we are going to talk about bivariate analysis. So bivariate analysis, bi means two. So it means we are going to do an analysis between two variables. And there are several, I've listed 3 here. analysis that we can use in bivariate analysis. So one is chi-square test. So chi-square test is mostly used for categorical variables. And I want to ask us, can we drop in the chat just 2 examples of categorical variables? Or someone can just unmute and tell us examples of categorical variables.
We have responses on the chat.
Okay.
Yeah. Someone is
Okay,
saying
great.
gender, marital status, level of education. There is a yes and no. Yeah.
Okay. All right. So categorical variables are variables that have categories. So for example, someone has correctly mentioned gender. So gender can be male, female, or level of education. We know that, level of income. So variables that are just categorized. And usually categorical variables are in 2 pairs. We have the nominal and we have the ordinal categorical variables. So I'm asking us again, can someone help us with, can someone tell us an example of ordinal categorical variable? And what does it mean for ordinal categorical variable? Someone can unmute and answer that. The difference
This one
between
is
ordinal and nominal variables.
Yeah, when we talk of ordinal variables, here we mean variables where numbers are used as first identification, then in an orderly manner. Like if you ask people to state the level of education, somebody can state primary, secondary, college, and maybe university, then you will see when you are assigning these numbers, you assign them in a given order.
Mhm. Okay. Okay. Thanks for that. Anyone else who wants to add something? Okay. Thanks so much for that. So ordinal variables have a natural ranking compared to nominal variables. So you can see, you cannot rank gender. It's just male or female. So you cannot say male is first and female is second. No. But you can say, we normally have these variables like, you've seen them, strongly agree, strongly disagree, and that strongly agree takes position 1, strongly disagree takes position 2, or likely, very likely, most likely, variables like that. And the example that we have been given, schooling, we have people in primary, we have people in secondary and tertiary level. So there's that natural ranking that a particular label takes position 1, another label takes position 2, and another one. So why is that important, and why are we stressing that? Is because when it comes to analysis, it's really important to know what type of variable do you have. So if you have an ordinal variable, how are you going to analyze that? And if you have a nominal variable, how are you going to analyze that? So for chi-square, we're going to check if the distribution of 2 categorical variables is if there's a significance or not. And then for the second test, we're going to do a t-test, which you're going to see in the software. And t-test is just checking on the distribution of a continuous variable. So can we drop in the chat examples of continuous variables? And then you can be checking. So what are some of the examples of continuous variables? Okay, I see very good responses. So we are following and we know. So it's very important that you know what type of variable you are dealing with, because that will inform what analysis you're going to take. So we are going to do this. So for example, if you want to check if age is different between males and females, you're going to do a t-test. We're going to check, so age, in that case, if age is, because age can either be categorical or continuous. If age is continuous, then we can use t-test to check if age varies among males and females. So males and females will be our groups, and then age will be our continuous variable. And then the last one we're going to look at is correlation. And correlation, it's just help us to determine the strength of relationship between two variables in a range of 0 to 1. And we're going to see in Stata how to know if that strength is significant or not. Is there any question up to there? So someone can be asking himself, if I say t-test is done for 2 groups, what if I had 3 groups? So for example, I had, if I want to check for the distribution of a continuous variable in 3 groups. So you want to check if the people in primary, for some level of income, if the age differs by level of income. So for 3 or more groups, we are going to use analysis of variance. We can't use t-test for if the groups are more than 2. So we're going to use analysis of variance. And we're going to see that in the software. Do we have any questions in the chat?
None so far done.
Okay.
Yeah.
All right. So in terms of multivariate analysis, we are going to see, in our case, we're going to see what variables we have and what we can do. But normally we have multivariate linear regression in which our outcome variable is usually continuous variable, and the predictors or our indicators can either be continuous or categorical. And as we have discussed, we know examples of this continuous and categorical, and that will inform us how we insert them into our model. So in Stata, there's a way we insert categorical variables in the model, and there's a way we insert continuous. So that's why it's important to know what kind of variable you have and whether it's continuous or categorical. So that is the first one, the multivariate linear regression. And then the binary logistic regression. Here our outcome is binary. So a binary is just 2 categories, male, female, yes, no, 0, 1. So, or 1, 2. So that's just a binary variable. And for that case, also the indicators or the predictors can be either be continuous or categorical. And the last one we're going to see, if our data allows, is ordinal logistic regression, which we have said you can work on if your outcome is ordinal and you're comfortable interpreting the ordinal results. And for this case also, the independent variables or the predictors can either be continuous or categorical. So we are going to see that in our software shortly.
There are 2 questions done.
Yeah. So I'll stop presenting that. So as I mentioned today, we're mainly going to do the practicals. That is on the different. Okay, there's some questions here on the chat. Do you?
Can I read for you?
Yeah, yes, please.
Yeah, the first one is, how can I differentiate logistic regression analysis and chi-square? And the second one is, how can we, okay, actually there are 3. So the second one is, please, can you elaborate on correlation between binary or categorical variables? And then the third one is, how can we manage missing values during logistic regression? it is a challenge to develop prediction model. But I think some of them you're already answering, but you can go ahead and maybe clarify.
Okay. So someone is saying, how can I differentiate logistic and chi-square? So in a logistic regression, you have an outcome variable. You can have an outcome variable that is, the outcome variable actually is a categorical variable, but your independent variables or your predictors can be continuous or categorical. So for example, if your outcome variable was an impact of intervention, so yes, no, then your predictors can be the socio-demographic characteristics such as age, occupation, income, and other variables. So you can have more than the categorical variables. That's what I mean. So you can have both categorical and continuous variables when you're handling logistic regression. But a chi-square can only work for two categorical variables. We cannot work with the chi-square when we are dealing with continuous variables. So that is the difference. Okay, so can you elaborate on correlation between binary or categorical variables? So a binary variable just takes two values at most two values, yes, no, male, female, just two values. And then a categorical variable, actually a binary variable is a sub-categorical variable. So categorical variables can take two or more categories. For example, level of schooling can be primary, secondary, or tertiary. So more than two categories, or income level below 1,000 USD, above 2,000, above 50,000. So that is a categorical variable. It can take more than two categories. But binary cannot exceed two categories. And then for the missing values, when you run a logistic regression, the model automatically drops the missing values. So you cannot manage missing data at the regression analysis. When you run that analysis, any variable that has a missing observation, the model is going to automatically drop that observation. So for example, if you had 1,000 observations and you tabulated your variable for age and you have 50 observations missing, so when you run your logistic regression, it's automatically going to drop all those 50 because it has to work with the variables that are complete for all observations. So you manage the missing data just before you work on your regression. I don't know whether I have answered all the questions and if there's any follow-up question.
There's
Minda,
one,
do you want to
yeah.
do you want to take that?
Have you seen chi-square and logistic regression used in bivariate analysis for binary outcomes? What should be considered in making a choice between the two? Godwin also is raising his hand.
Okay.
Maybe he can continue.
Okay.
Godwin,
please speak.
Good morning. Can you hear me?
Yes, he can hear you.
All right, thank you for the class. I will just ask him, in a place where you have up to 3 categories, can
Yes.
you use logistic regression, or do you do multinomial logistic? There are circumstances that you can have more than 2 categories. You mustn't have binary. So what do? Do you throw the variable away? And then if the variable is not normally distributed, something like viral load in HIV patient is not always normally distributed, or if it's ordinal, What do you do? How do you model it?
Okay. All
Can
right.
I
Any other question?
Can I recommend something?
Yes.
I know some of these questions are a bit slightly complex, and they might disorient some people. So I would recommend you first tackle what you wanted us to tackle today, and then we can deal with them at the end of the session, so that you build as you continue building for the sake of people who are beginning. What do you think?
I think that's
Nunse, you
fine.
can advise. Yeah, you can also advise, because I'm worried some people might feel like now they are disoriented completely as you build on, I don't know.
Okay.
Yeah, there are those ones that
Goes
I'll
with,
respond on the
okay.
chat. Yeah,
Okay. Yeah, please just drop your questions on the chat, and
on the
then
chat. Yeah.
we will keep answering them before we finish the session. All right. So I want us to move to the software. I hope everyone has their software installed, the Stata software. Whichever version you're using, it's immaterial. So what the commands should be uniform, commands you're going to use. So don't worry so much about your version of the software. I don't have software installed. Okay. So just one person who does not have their software installed. So please, I want to share the software that this is my screen. I don't know what you can see. I don't know what you can see on your end. Can someone confirm?
Yeah, we are able to see your Stata windows, both the main and the do files.
Okay.
Yeah.
So I usually like overlapping my do file and my main window, so that whatever, as Daniel Maina mentioned yesterday, whatever you run on your do file, you want to see if it's working or it's an error. And just before I proceed,
Sorry,
yes.
you can actually tile them so that you have them like horizontally next to each other rather than overlapping.
That's okay. That's still okay. That's a good suggestion. So is there any other concern? Okay, if not, before we proceed to the data set that I want to show us, so this, as Dan mentioned, you can choose your preferences of how your data looks like. That one was we mentioned yesterday. You can choose, you can click on fonts to increase the font size or reduce. So I usually use 12 for my case. So for preferences, you can check whatever you want, light, dark, or something like that. You can actually check on here, you want your results to appear. How do you want your results to appear? How do you want your viewer window to appear, your command window, data editor window? So just what is you are comfortable with, and that is what you select. So over here, I have our first task is to do descriptive analysis. And for descriptive analysis, I want us to use yesterday's knowledge that Dan shared with us to load the data called pregnancy during COVID. So it's pregnancy during the COVID-19 pandemic. It's in what was shared. So can we load that data set? Do we have people with challenges of loading the data set? I can repeat the process. Do we have people with challenges of downloading the data set? Of loading the data set, I mean, to your Stata window? You can just unmute and say if you have a challenge of loading. The others, you can confirm if you have loaded that data set called pregnancy during the COVID-19 pandemic. Just drop in the chat and we can see whether you have loaded the data set or not.
Sorry,
That is-
Dan.
yes,
Daniel. Is this the one that we shared yesterday, or
it was already in the folder, pregnancy during COVID-19. You shared yesterday, yes. Is it there? Okay, let me repeat where is the data set? Okay, let me see. So the data set called pregnancy during COVID-19 is in Excel or CSV format. So when you want to load a data set that is in that kind of format, you are going to check this. You can see where my cursor is. It's on file. So you're going to click on file and you can see what that brings. So you're going to import a data set. And when you put your cursor on import, you're going to see different options for importing. So one is XLS, the other one is CSV, and the rest of it. So that data set is in CSV format. So you just click on CSV, and then it brings a window like this. I hope we can see that window. So there is on your right, there is a folder here to open. So it will tell you to open and you can open. So if you have downloaded that data set, you go to where you have downloaded that data set and click on it. So for my case, I'd saved it somewhere here, pregnancy during the COVID. So for your case, you just go where you have downloaded the data, that data set and saved it. So for my case, it is in this mental health data price folder. I'll just click on that and open. All right.
okay.
So
I think
yes,
they don't have this data set. Kindly put your email in the chat box. I'll share with you.
okay. Thanks, Melissa. So that is how you load that data set, and once you confirm everything is okay, you check quote binding is strict, you import first row here as variable names, you just check that, and then the rest of it is okay, and then you just click okay. So it will tell me to replace my data in my memory. I don't have a problem with that. I'll just say yes. So it will give you something like this.
Just give us some minutes.
Yes, please, no
We'll
problem.
share with
Oh, so many people don't have the data set, cannot access it.
Oh, yeah. There are also quite a number that were not with us yesterday. So that could also be the
The
other
reason.
reason. But it's okay. We'll just share with all of them.
No problem.
Yeah.
Otherwise, I hope the process of loading the CSV dataset is clear. But if you have been lost anywhere, you can just drop a message on the chat box and we can follow that. You can just repeat. So can we know if people have received the dataset?
Yeah, I've already shared for most of them, so you can continue.
Oh, great. So That's okay. So that is how you import your data set. And today we are going to use two data sets that are planned to use. There's one on CSV. Not always you will have data on CSV. And there's one that is already in Stata format. So we are going to see how to load that also to our software. So I have my data set. So the first thing I usually do, this is the command window. I just type BR. As Daniel mentioned yesterday, BR stands for browse, and you're telling the software that you want to see how your data looks like. So that is how we use browse. So you can just type browse on your computer and then click enter, and then you will see your data on the data editor window. And then you can just look at how it looks like. So usually that one is just for, you just want to see how your data looks like. And so as let me just repeat, as Dan mentioned yesterday, once you have your data imported, you want to keep your commands in a do file. So you just copy the import command and then paste that command into your do file. I've done mine here. So this is that step. And before I forget, usually when you do anything in your do file, comment it out to see what step are you taking, so that someone else, if they are following your do file, they are knowing that John was this step was for loading a data set. This step was for A, B, C, D. So everything you do, you want to comment it out, so that if you're sharing this do file with anybody else, they can be able to understand all the steps you took for data cleaning or for data analysis. So the first step is to browse, and browse just checks the data in the editor. And then you want to see how you have all your variables, the type, the variable type, whether it's string or numeric. You want to do describe. So you can just do describe.
Sorry, Mr. Daniel.
So in the command window or in your do file, any can do. You don't have to write the entire describe. You can just say this, and then you press enter. When you press enter, this is what you see. So what this tells us is our observation has 10,772 observations. So this could be instances, households, or people. And then the variables in this data set are just 16. So then a table is populated down here that shows you on the first column the variable name, the second column how that variable has been stored, at the display format, how it will be displayed in the data editor, the value labels, and the variable label. So we mentioned, when I was presenting, I mentioned something about labeling of our variables. So if someone comes and sees maternal age, they can see that the label of that variable is maternal age. Edinburgh Post, this is called Edinburgh Postnatal Depression Scale. So they are able to make sense of what that variable means. So this is what the describe command does. It tells you what variables you have, how that variable has been stored, the display, and the value labels, and the variable label. So if you want to just describe a single variable, what do? You just say describe, and then you mention that variable. So say I want to describe language, just language only. I don't want to describe everything in my data set. I just type describe language. So it tells me the variable is language. It is a string variable, and the variable label is language. You may want to describe more than one, so you can just say describe Nico and language and threat and life. So this. So you just select the number of variables you want to describe. If you want to describe everything, you just leave the variable list blank, and it will describe everything like this. Okay, so that is to describe. And then in some instances, you want to see the variable labels. You want to see whether your variables are missing, whether some observations are missing in a variable. So you will do codebook. You can just type codebook on your command window or on your do file. You can just type codebook and run that. So when you run codebook, it gives you a big screen like this with every variable. So it gives you a detail. For example, let's pick on maternal education. So codebook tells us that the type of maternal education is a string variable. It has 6 unique values. And it's the observation that are missing here is 177 of the total. So it means we have 177 missing details here. And now it tabulates for you. It gives you a table of the frequencies. So 41, 17 undergraduate degrees and the rest of this. And then you can see 177 is missing. And then it tells you if there is anything. So variable has embedded blank. So it tells you that. And for numeric variables like depression, so the type there will come as numeric. It gives you a range, how many units, how many are missing in that variable, how many unique values, what's the mean, and what's the standard deviation, what are the different percentiles for that variable. So when you do codebook, you can explore. You can actually see already in this place, I'm missing 4038 values. So it can already tell you for each variable, what exactly are you missing? How is that variable stored? And what are the values for that data? So that is for when you do codebook. And as we did with describe, you can just codebook a few variables. So you can do codebook NICU and language. So it will just codebook the 2 variables that you have specified. Okay, then now that is all about seeing how your data looks like. You have not started doing anything. So if you want to get a summary of all the variables in your data set, you just run the command summary or sum in short, and it will run. So as you can see in my do file, I'm commenting out. What does this command do for me at every step? You don't have to do it at every step. When you feel like it's very important, you can do that. But for this case, I'm commenting out to just show us what does sum do in this case. So if you run sum, it will give you a summary of all the variables in your data set. So it has the first column lists all the variables. The second gives you observations. The third, the mean, the standard deviation, the minimum, and the maximum. And that is just to give you a brief overview of how your data looks like. So as we have done with the first 2 commands of describe and codebook, you can sum a single variable. So say I want to sum maternal age. I just run sum maternal age. Now, what does this mean? It means for maternal age, there's data for 10661 observations. The mean maternal age is 31.8446. The standard deviation is this. The minimum age that was recorded is 17. The maximum age recorded is 49.7. So you can actually summarize age. If you had a variable for age, you just summarize it. So you just sum maternal age and you get this. So if you want more details of this variable called maternal age, you will just type sum maternal age, this maternal age, and then you can just say detail or date, just a short form. So if you type detail, it gives you all the rest of it. So the percentiles, the smallest, the largest, sum of weight, variance, Q-ness, kurtosis. That is if you're interested in more details about that variable. So you just add detail and then it will give you the details of that data set, of that variable, I mean. So that is what I've done here. And then as we continue the summary, so for instance, you want to add a condition. You want to add a condition to your summary. You just want to sum maternal age for some people who have some level of income. So first, you need to know what variable you're interested in. For example, I'm interested in household income. So you want to tabulate that household income and see, this is how household income looks like. So I want to see the age of people who are in this household income category. So I want to copy that. So you want to sum maternal age if, so you add a condition if. Now, if what? If household income is that. So that means you're only interested in people in this category. And when you press enter, you will see that the people in this category of income are 1,008, and that their mean age is 34.2. This is their standard deviation. This is the minimum age recorded for that category, and this is the maximum. So you can do that. You can do as many conditions as you want. You can combine conditions, but I won't do that now. You can combine conditions. You can say, I want to sum maternal age if household income is this, and their NICU stay is 1 or 2. So you can always combine. We can just do one that combines two conditions. So say NICU stay is no, yes. And I said, if you want to describe this kind of variable, you just say des NICU stay. It is a string variable. So you want to sum maternal age if household income is that, and so what you do for and is this symbol here, and so you want to add a condition that you are only interested in people whose NICU stay observation is a yes. Yes. So that is what happens. So you have added, you have combined two conditions. So this sum only gives us those whose household income is 2,000 USD, and their NICU stay variable is a yes. So this is what you get. So you can combine as many conditions as you want, just to tailor the analysis to your needs. Whatever you need, you can just do that in using the conditions. So that is what I've done here. So there is the other statistic for, you want to sum by group. So I want to sum maternal age by delivery mode, the mode of delivery. So you just run that command and it tells you, so this is missing. If delivery mode is nothing, this means it's missing. So we are missing 5,000 observations. Delivery mode is this is their summary. If delivery mode is this, then this is the summary for that category of people. So you are just going to run by sort, delivery mode, and then you sum maternal age. Is there any question up to there? Do we have any questions?
Someone is requesting you repeat the summary command. Maybe you can do it briefly for them.
Okay.
Yeah.
So summary command, there are many options. You just run the sum, SUM. If you want to get a summary of everything in your data set. So you can type it on your do file or just on the command window and just say sum. And then that's what you have. So you can see it has several columns. the observations for that variable, the mean of that variable, the standard deviation for each of the variables, the minimum and the maximum. So I said, if you want to sum just for one variable, you just click that variable, sum equals stay. So that is the sum. And then if you want a sum for age, maternal age, you just say just sum maternal age. You can add the sum with a condition. You just want the sum of maternal age if Nico stay is a yes. So you just say Nico stay is a yes. So that means you are summing just a particular cohort you are interested in. So that is what you get. So you can add a condition, and as I said, you can add even more than one condition. So that is what the sum does. And I said, if you want more details, the variance, the kurtosis, the skewness, you just add detail, some maternal age detail, and then it gives you all the rest of it, the percentiles, the smallest, the largest, and the variances, and all this. So you just add detail, and then you can see it populates for you all this information. All right, so let's move to...
Maybe, Daniel, can I interject a bit?
Yes.
So we can use a combination of two conditions, or you can use an or. If you want to pick at least one of the conditions. So you can also show them that, so that instead of using the ampersand, you can as well use the sign for or.
Okay.
Yeah, so that somebody is either, like in your previous case, you wanted a summary of, I think, children or mothers who had children admitted in the neonatal ICU.
Yes.
Or maybe you can also add another condition so that you pick all a summary of a person who actually met one of the conditions rather than both conditions. Yeah.
Okay.
Thank you.
Okay. Thank you so much for that injection. So when you want to add a condition that takes either, so if someone has Nico stays yes, or maybe their delivery mode is vaginal. So I think there was, I hope I just typed it correctly. So this means you use the slash, the straight slash, for or. For the and, you use it, that, how did you call it? Ampersand. Use that.
Ampersand, yeah.
Yeah, for and. So for the or, you just use it. So you want to say, I want a summary for maternal age if they stayed in a neonatal ICU, or the delivery mode is vaginal. It's vaginal. Yeah. So this picks either. If either is accurate, then it picks any of that and populates for you this information. Thank you so much, Dan. Any other addition? I'll just copy that command to here. Okay. So for frequency tables, we usually use the tabulate command in Stata. So you just type tab and then the variable, and then you can give an option of missing if you want to check if that variable has missing values. So you if you run this, that is what you get. So the first row is missing 177, and then you have all the rest of this. There's a command I usually like to use. It's called FRE, which stands for, I think, frequency. So if we had labels for our maternal education, and we say FRE maternal education, you don't need to specify missing because automatically it will give you missing. So that is what it does. What this command, I think if you run it on your end, you may find an error because maybe you have not installed it. So to install a command like FRE, I think the command is usually SSC install FRE. So you can just type that on your command window and run. So this is what my Stata is telling me, that it is checking if this FRE is not already installed, and it's telling me that all files are already exist and are up to date. So what this is helps you with is, if we had like the labels already, so that college is 1, doctor is 2, and the rest of these, then you will see on this table that this gives you 1, 2, 3, and we will see in the data set that is following, or we can already see here, if we record this variable, how this command helps you to just see the variable value and the value label. So you will see that in the as I present in the next data set. So if you have not installed this, you can install it. It can help you if you don't want the hassle of writing missing with this. So this is what this gives you, and for me it looks nice. Has anyone tried to install this and it has refused? Do you have any questions from the chat? If not, so I've said
someone is just confirming.
Yes.
Yeah, Vincent is saying they've been installed successfully. I hope the rest will also confirm on the chat so that we are sure they are following.
Oh, great then. Thank you.
Thank you.
So I've said if you want a table of any variable, so you just type tab and then you see maternal education and then you say comma missing. But as I've said, you can use the FRE command and then you'll just see what happens to maternal education. So this is what you see. And you can interpret and say, from my survey, you have, now we are assuming these missing are part of our data set. So if they are not, and we have dropped them completely, then these percentages would likely change because they're taking about 2% of our data. But if you're interpreting this table as it is, then you will say 25.62% of the respondents are attending college or have attended college or trade school. And these are the percentages. Okay. So what if you want to tabulate, you get a table of several variables at once. So that is what I do here. I just tab 1. So after tab, you just add 1 and then you list all these other variables. So it will populate for you tables for NICU, stay, language, household, maternal education, just examples. So this, from the Stata window, this is what you will see. And you can interpret using the percentages. So these are just, so what about if you want to check distribution of two variables? So let's say maternal education and delivery mode. So I add row so that I get row totals and row percentages. So if I say row in this, it gives me row percentages in terms of row. So you can see my row percentage adds up to 100. So that is, so if you're interpreting like a cell like this, it means those who had Syrian delivery mode and are in college or trade school are 32%. Okay. So, and then those in 67% of those in college or trade school are delivered through vaginal mode. So that is how you interpret cross-tabulation. If you don't like this key, this table here, if you don't like it and you don't want to see it in your output, you just type row and then you add no key. You just say you don't want the key there. So when you run that, it doesn't give you that key. So that maybe your work is neat, and maybe as we will speak about a log file, your log file does not have all the keys. So if you don't want those key that tells you this is a frequency and then this is a percentage, then you can just type no key there. So that is row. And if you want to do column, you just say comma column, just COL. You want to tap the two variables, but then you want the column percentages, you just type comma col. And then you can see now the column percentages are the ones that are summing up to 100%. Okay, so what if you don't want these frequencies to show up? You just want these percentages. Usually when we give a table of descriptives, you can choose to put your numbers at the top and then just percentages within the table, or a combination of the numbers and the frequencies and the percentages. So you can choose what fits your need. For example, if you don't need the frequencies, you just add a command. You just add something called no freq here, the one I'm highlighting. So if you do that, it will only give you percentages here. Now, this is how the table looks like if you add no freq here, no frequency. So it doesn't have all the frequencies, so it just gives you the percentages. And as this command says, these are the raw percentages. So you do the same for column percentages and you'll see what happens. So this is the column percentages when you do no frequency. So, and then what if you want particular statistics for a variable? So for example, in my case, I wanted to just know the number of respondents, the mean and standard deviation for this variable called gestational age at birth. So I'll use a command called tab start and then specify what statistics do I want from this variable. So in my case, I want the n, which is just the number of observations, the mean of this variable, and the standard deviation. So when you run this, that is what you get. So the variable name is gestational age at birth. The people who have responded to that are this. The mean of that age is that, and this is the standard deviation. So if you want to know the minimum and the maximum, you just come and add here, mean, let me type the correct thing, mean and then max. So minimum and maximum. So just add that and see. It will give you the minimum age that was recorded was 24.86. The maximum was 42.86. So you use tab start to specify what statistics do you want to generate from your variable. So you can choose any variable that you want to explore and then exploit using this tab start command. I don't know if there's any question up to that.
There's one question or concern for Abebe.
Yes.
When they they tabulated maternal age and it complained because the values are too many. Yeah, maybe you can explain to them maybe the range of them, the maternal age had so many values.
Yeah, it's 1006. It's 10661. Did you get an error? The person who tabulated. Did you get an error? because that can only happen if that's an old version of Stata and the memory is not so much. But these other versions of Stata should not have a problem if you tabulate whatever the number of observations it is. Abebe, what error did you get, please? Is Abebe here? Can Abebe hear us?
What did you say?
What did you see an error on your window? An error?
It said that too many values.
Too many values. I don't know what that's supposed to mean.
Can I share my screen?
Let's see. Yes, I think you can just share, see what happens. Yeah, we see. We can see what happens with your screen.
Is it visible?
Is visible? Can
I
you just
think-
tab? Yes,
Dan,
Dan.
I
Yes.
think it's I think he was trying to cross tabulate because there are two variables. Maybe birth length has also many other variables. You know, in the first instance, maternal age has many values, and then
Yeah.
birth length also. That could be the problem. So he can try to tabulate only one.
Okay, Dan. That is the reason, yeah.
Yeah.
Can you type there? Can you just do it there, we see? Abebe.
What?
Share again and do it there, we see. Can you just tab one, tab maternal age, and then we see if it gives an error. But you have started 18, it should not give you any error. Yeah, that should be okay. All right, thank you. Any other questions? Yeah, that should be okay.
But when I combine them together, it says that too many values.
Yeah, if you combine, it means we have a very large column for both height. Is this length and the weight? So it can't fit in the Stata window.
Okay.
Yeah. Do we have any other questions from the chat? Someone is asking about the mode. So let's see. Oh, am I sharing my screen back? Or I've forgotten. Okay. Can you see my screen?
Yes.
Thank you. So someone is saying, can we check for mode if you use tab start? Let's see. What's the command for mode? Let me see if this will work. So mode, is it without E? Let's see if you can get help. So in case you have any challenge in this data and you want some help, you can just type their help and that if you have help with the frequency, help with ANOVA, help t-test, so you just type their help and then with what you want to know. I can't seem to find any what is this called? I can't seem to find something for mode, how you add mode to this data. Then you check that for me and then you can respond.
Yeah, no problem. Let me check it out.
Thanks. All right, so there's so much we can do with the data set that we have, but I know we are continuing to practice on this data set. And the data set that I'm about to share also, we continue to do almost the same things, but now maybe different analysis. So if there's no question on this part of descriptive statistics, I'll move to bivariate statistics, where I saw so many questions as we started. So at this point, maybe we'll answer them. So if you want to load a new data set, usually you want to clear what's in the memory of its data. So one thing you will do, you just type clear in the command window, or you want to clear in your do file. So you can type clear here at the command window, or you can come to your do file and clear. So that means when you're loading your next data set, it doesn't give you an error that you already have, the memory has some work it's doing. So just clear. If I clear, everything will just disappear. So what I want us to load now is the data set called, is it called? The MHDP practical data. All these data sets are just example data sets. And so we know the data sets you may have may not look like the ones that we are sharing, but this is just for to share some of these commands that we have with you. So there is that data set called MHDP practical data. Can you see it? I want us to, I will explain. We'll explain some of the questions then we'll be taking from the chat. So can we see the MHDP dataset? It's a Stata file. So I want to show us how to load that Stata file into a software. So can everyone see that data in the folder that was shared? So just type yes to confirm, please, so that we save time. If you can see that, can people see that dataset, MHDP practical? Okay, I can see so many yeses, so we can proceed. So if you now, if you see that data set, there are several ways of loading a Stata file. It's very easy for you to load a Stata file into Stata because Stata already understands. One way is to come to your control window and press Control O. Control O will open a conversation and will ask you to specify where your data is. And then you can just double click on that data set and open. So if I press Control O on my computer, it takes me here. And we are using MHDP practical data, which is this. So I click on it and open. That is one way. So you Control O. And then there's another way you can do. You can come to File here and open here. And then it takes you to the same, to the folder where, and then you specify where your data set is, and then double click it, and then it will open. And the last option that I know of is you can come here. You can see this thing. This yellow folder. It just tells you to open. So you just click on that, and then you will open that data set. So those are some of the ways you can open a Stata file in Stata. I don't know whether that is clear and understood. So there's Control O, it will open. Or alternatively, you can come to File and there's Open dataset here. You can just click on that and then it takes you to a folder. Alternatively, you can just click on this, Open. tells you to open, and then you can just open. So can we confirm that we have loaded that data in Stata? Is there anyone with a challenge loading the data set? That should be pretty easy. Usually, you can just go onto that data file and even double click on it. It will just open in Stata. That's another way. So if you have a Stata file, it should be easy to open. Then kindly share. I didn't get the folder. So we have people who cannot see that data set. So just check on the folder that was shared with you.
But I'll try to also send to the ones I can.
Okay.
Yeah.
Okay.
Yeah.
All right. So this is the data set that I'm going to use very briefly before we take any questions and before I invite Maina to add any contributions he may have. So for this data, I've just copied this command here to my do file so that next time I just open Stata and run that. Now, you need to have a background of what is this data, how does it look like? And as we said previously, you can always browse, just type BR and see how this data looks like. This is how it looks like. This data was collected among university students to measure depression, to measure anxiety. And yeah, there were 3 outcomes here: anxiety, depression, and then there was attention deficiency, ADHD. So there are 3 outcomes. So it was collected among university students. You can always describe the data set to see. So just type this, and then you'll just see how this data looks like. So my data set has only 334 observations and 48 variables. So those are the basics, preliminaries that we have tackled just before we open this data with using the other data set. Now, what do you want to do here? We can learn something about recording or renaming your variables. So for example, you can see from where from this variable window, there is SD1, which is already labeled. I've already labeled this data. So it means, what is your gender? So this variable is asking about gender. This is asking about age. This is asking about study, year of study, and the rest of this you can read. So maybe you don't like this name SD1, you just want to call it gender. So what do you do? If you want to do that for just that variable, you just rename. You just type rename, REN, or you can just type it in full. SD1, you want to name that gender or sex. So you can just say any of that. Rename SD1 sex, and then you press enter. So that will rename this variable to sex. What if you want to rename several variables? You want to rename SD2, SD4, SD5. So SD2, you'll say age, this will be year of study, this will be academic performance. So you want to rename them at once and not one by one. So you can also do that. So that one, let me check where I did that. Why did I rename this? So,
178. 178, I think so.
178. Yeah, okay. I think I first generated the variables before renaming. Okay, but it's fine. So okay, so let me just go back and load this data set again. So if you wanted to rename several variables, let me just type the command here. So you just rename. You can just click on all this. If you click here, the variable will be assigned to the command window. You just click all the variables you want to rename. So maybe you want to rename all this. So just rename, you put a bracket for that, and then you open a new bracket where you will list the new names. So SD1 will be my gender. So I want to name that sex. SD2 will be my age. SD4 is year of study. So I just say year of study. So as you name your variables, you ensure that there are no spaces. So if you say year of, that means if you leave that like that, it won't, it will pick this as different variables. So if you say year, then you just put an underscore to just show that that is one variable. And then that is SD4, SD5 will be academic performance. So I can just say academic performance. And then you can just rename the other one is SD8, satisfaction with academic programs. So I just say satisfaction academic. So if you want to rename several, you can just rename them. And then just press enter. And then it has renamed all these variables the way we have listed. So that is part of like it, you just do what pertaining your need. Are you comfortable using the variables the way they are, or you want to rename them? So that depends on you. So for my case, let me load the data set. I want to load the data set again. So for my case, what I started to do, because I wanted to do analysis, I generated the variables for analysis. So SD1 is gender. So I want to generate, I usually like question 100, question 100B, and A, B, C, D. So that is what I did. You can do what suits your need. So I just said, first, you can just tabulate this A and see what this is. So there's female and male. So according to you, you want to assign female a 0 or a 1, males a 1 or a 2 or a 0. So it really depends on what you want to do. So for my case, I wanted to assign males a 1 and females a 2. And using this variable called SD1. So I say generate Q100 x1 if SD1 is male. And then I replace Q100 is a 2 if SD1 is a female. And then I label 1 is male, 2 is female, and then I modify. And then I label with the labels that I've defined. So when I run this is what you have. So it really depends with what you want to do. So if, for example, if you want to say males is 0, so you just change that to 0. And females is a 1, you just change that to 1. So here, this will be 0, and this will be a 1. So if you run that, it will tell you I've already defined Q100. So if you want to run that, you'll have to drop Q100. You drop it, and then you rerun this command, and then you will see. Then you can now tabulate sex. What did I generate? Oh, generate, okay, Q100. This is what you will see. But as I've mentioned earlier, you can just type FRE Q100 and you will see what it gives you. So this is what I was saying before. So if you type FRE Q100, if you have generated it on your end, it will give you the value and the value label. So yeah, so I usually like this command so that if in case there's anything missing, it will just give you already here. So I've generated this variable. So for the age categories, I do the same.
Oh, someone is Glorious Jesang is requesting you to repeat.
All right.
And someone else is also asking, what does cap mean?
Especially in replacing.
Especially in, sorry, come up again.
At the gender issue, when he was recording and replacing.
Oh, the gender issue. No problem. Just repeat. Yeah.
Okay. So I have my variable SD1 is a gender variable. So if you want to tabulate it first, so you tap SD1, you get, this is what you have. So you, as the analyst or as the person pre-processing this data, you want to assign females are 1, males are 2, or vice versa, or females are 0, males are 1. So what you will do, you generate a new variable. Usually it's good so that you have your original data set and maybe the ones you have generated together in one data set. So I generated a variable I call Q100, and I assigned Q100 0 if this one is male. So if it's male, it will Q100 will be a 0. If it is female, Q100 will be a 1. So I replace Q100 is 1 if SD1 is female. Now, why I'm doing CAP, which is capture, this usually if I run my do file without capture, it will give me an error and tell me I've already defined these sex labels. I've already defined 0 and 1s. So I capture any error that that it will bring, and so that it doesn't give me any error on the window. So let me try to run without capture and see what happened, and without modify. So I usually like those two so that I don't get any error. So if I run this, you will see the error that it's giving me. It tells me that label sex already defined. I've already defined my sex as 0 is male and 1 is female. So usually I don't want this error to appear. That is why it will capture that error and drop it. So that's why I use cap lab, and then I just say modify. So if I do that, even if I've already defined the label and I'm rerunning this code, it will not give me an error. You can see now there's no error on my window. So that is why I'm using capture lab. Usually, if you use modify, that is enough. If you use both, it's enough. So it depends with what you choose. So that is what I do. And yeah, I don't know whether I've answered the question.
Yes.
All right, thank you.
Sorry,
So,
Dan.
yes.
Can I emphasize there? Just go back to your do file. One thing you really need to note, participants, most Stata accepts, will I say the short form of most of the commands. So like just like Dan has said, cap really means capture, and then LA is actually label defined, def is defined. So the other thing that you need to remember and note, machines would not really work with strings. They don't understand strings. When you are doing analysis, you need to have transformed your variables into numbers so that when you are doing analysis, the machine can actually generate frequencies. It can generate those proportions. So that's the reason Daniel is actually doing one thing. He's combining a number of skills. One, he's not tampering with his original variables. That's why SD1 is the original variable that was used to capture gender for the respondents, right, Dan?
Yes, right.
SD1, yeah. So he's basically generating a new variable that will hold numeric numbers that represent gender. So that's why you are seeing on line number 114, he's using the command generate, although he has shortened it to gen. Then he's generating a new variable called Q100, and he's assigning it 0 if the original variable has the value male. He's also going into the same new variable that has been generated in line 114, that is on line 115. He's putting a value 1 in case the original variable contains the string female. So basically he's generating a new variable based on the original variable. So that's one of the skills that you really need to keep. Don't tamper with the original data. Don't tamper with the original variables, because sometimes something might happen and you may want to go back and really check whether anything went wrong during your data preparation. Then on line 116, if you can remember, sometimes if you give someone your data set with values, they may not really make sense of what the values mean. So that's why he's actually defining the labels, value labels, so that when somebody sees a 0, you'll definitely know that the 0 stands for male and the 1 stands for female. And then he's now adding those other options to allow the code to run. Over to you. Thank you, Dan.
So much. Thank you. Yes.
Question done there. So in line 116, if we did not define that 0 is male and 1 is female, then we run that code without 116. You will only have 0 and 1 on your tabulation without locating male or female in either 0 or 1. Eh?
Yeah,
Pardon?
sure.
I didn't get it clearly.
Repeat, Vincent.
Okay, I was asking in
Yes.
line 116, where we have the coupler. I think you have said that is define what 0 is and what 1 is.
Correct.
So
yes.
If we run that line of analysis from 114 to 117 without 116, then it will bring a tabulation of just 0 and 1 without indicating which one is male, which one is female.
Yes, correct. So we can just do that and you see. You're right. So I'll just drop the variable that I generated and then just run it without that. So if you want to comment something out, you just put a star. There's a star there. You can put double slash. If you put double slash, it will just comment something. That is a comment. If you want to comment a large section, you can just put slash and then a star. A slash and a star, it will comment everything below that until you add another star and a slash. All right. So those are just for comments. So back to what we are doing. So if I drop that line 116 and run this, so you'll just see what happens. And then now I tabulate Q100. So it just, what did it do? It already defined, so I can just drop. Let me lab. How do you drop a label? Let me see. Lab drop. Is it drop lab? I think okay, now drop the label until I drop this label because it's already in the memory. So I've dropped the label. So let's say we have not done that. So I'll just run this. Already defined. Let me drop it. So I'm dropping it. Just okay. So that's okay. So if I tabulate Q100, so this is what you get. It doesn't have the value labels. All right. So until you define what 0 is, as Daniel was saying, as what 0 is and what 1 is, whatever you will see is just numbers. But if you label this as we have labeled, you will just get, so now if I run that, and then now tabulated Q100, I just rerun this command, you'll see this. Or that, or you can do that. So to confirm that you have actually done the correct thing, you can always cross-tabulate with the former variable. You want to cross-tabulate your new variable and the former and see what happens. So you don't want any males to be assigned female, so you just want male and male, female and female. So you have something like that looks like this. So you are sure that whatever you did is correct. All right, so you do that for different variables, depending on how you want to categorize them. Sometimes you want to combine categories. I don't know that, I think there's one example where I combined the categories. And yeah, so I generated the variable for gender, for age. I generated it here. So it's just the same concept. And then I generated for year of study. We will share this do file. Just the same concept. So you first check what does the original variable has and how do you want to record it. So that is what you do. This is academic performance. You can just see how I did that here. So for academic performance, you can just check that one again. So that is academic performance is what is SD what. So academic performance is SD5. So you want to tab SD5. So that is it. So you want to generate a variable and then assign this one maybe a 0, this one a 1, and this one a 2. So that is what I do here. I say 1 average, 2 fair, and 3 good. So that is that works for no, that is the flow of what you do when you want to generate these new variables that now contains the numeric numbers that can be used for analysis. So it really depends with how you want to recategorize or record your variable. So for satisfaction in the academic program, that is what I do. And this, I don't know if there's any question with recording and generating new variables. Do we have any questions? Okay, so
I think there's a question.
Yes.
Sorry.
Yes.
This one is about the Stata. Where did you get this data from? No, that one I respond to. Please proceed. Yeah.
Right. So after you have generated your variables as per your need and as per the categories that you desire, my next step will be to rename them.
Sorry, where did you get this data from?
This data from it was collected from school by one of the projects that I was handling. So just this is just a section of it. Okay, thank you.
How did you impute this data into the Stata?
How did I load it into Stata?
Importing.
Import.
Yeah, it's actually importing. Yeah.
Okay, my data set is already in Stata format. I don't know whether you can access the folder with the data set. You can access the folder?
Once he shares his email, I'll send it directly to him.
Okay.
Thank you.
So all right. So once you have that, you can come here. You can come here to open and then open to where you have saved that data set. Or you can Control O and then it will take you to a folder where you have saved the data set. Yeah, so those are some, or you can just go to that data set where you have saved it and then just double click on it and it will give you it will just give you the data set on the window. Okay.
Can I ask?
Yes, please.
I've tried to open the data set, but it's telling me you need more recent version of Stata because
which version are you using?
13.
Okay, sorry. How do you install this Stata kindly? You know, I was to do Python, but I'm trying to log into Python lectures, but I'm getting trouble to load. It was easier to load into your link. That's why I found myself into this Stata. How did you install this Stata?
Okay. So usually Stata is not a free version. Stata is purchased. You actually buy Stata. So if you are in an organization, you may have an organizational license and they can install it for you. If you're not in an organization and you're using it for personal stuff, then you need to purchase it. So Stata is actually not a free version or not a free software. So you need to buy it, or you need to be installed for by if you are in an organization. Is that right, Dan and Muluse?
Yes, you have answered well. I'm at disadvantage because I just wanted to input in the data to export the data into the Stata, which I don't have it. That's why I'd opted to use Python, but I can't log in into Python. That's why I found myself here. But still, this can be helpful. Only that the challenge is it's not
You don't have
accessible.
Stata.
I don't have.
Okay, maybe Muluse can resend you the link for Python, but if you can follow and then maybe get this version the Stata later from someone, or you can purchase, then it's still fine. You're still welcome to stay. All right. Is there any other questions?
Thank you. Before I stay, how different is this from Python?
Well, the softwares, there is usually not so much difference in terms of what is needed to be done, but the commands can be different. The commands and the interface. So when you open maybe Python, you want to work on PyCharm or you want to work on Jupyter Notebook. So the commands could be different, but the reason you are doing something, if you are doing like describe the one we are doing, is the same. So maybe just checking on what command do you use to describe a data set in Python or like that. So usually the softwares are cross-cutting. Whatever you do, if you're doing visualization, it's almost the same things. Just that the software does not look like, if you open a Python Jupyter Notebook, it doesn't look like this. So it looks different. All right. Is there any other questions on what we are doing on recording? So that we can just, I can finish up before I let Daniel, if you have anything to continue with. I'm about to finish the practical session. So I've generated the categories for analysis. Dan mentioned the importance of this is because we can't do analysis with the string variables. And I'm generating new variables because I want my data in the original format and my new variable. So that's why I'm generating. And then if you have, I've generated Q100, the ones I've labeled here. How did they run? Okay, so these ones are already defined. All right then. So then I want to rename them so that if someone sees Q100, they see sex. If someone sees Q100B, they see age. So you can just do that in one line and ensure that each variable is connected to the right label. So I'll just run this rename command. So you just type rename and the variable that you want to rename and then the new name. So the syntax is rename. So you want to say var1. That is the variable you want to rename. You want to give it, the syntax is usually rename old name to new name. That is the syntax. So these are the old names first, and the new names without any quotations. So that is the syntax. So you can do one by one, or you can just combine them. I know one by one is tedious, so you just want to combine all the renaming variables. So this is a syntax, rename old name to new name. All right, so if I have all that done, now I want to check for bivariate. I've mentioned about chi-square. I've talked about t-test. We've talked about correlation. So we want to see those things in the actual sense. Now, you can use a loop to check. Let me just see. So I have the bivariate analysis here. So I want to tabulate I didn't generate for each of these variables. So I need to generate the anxiety score first. They generate it. Okay. So we want to move to bivariate analysis. So what I want to see is the association between anxiety scores and there's someone who should be muting, please. Stanley, do you mind muting, please? All right,
I've
thank
done
you.
that, please.
Thank you. So I want to see the association between anxiety and several socio-demographic variables. So the first thing is to see what actually is anxiety. As Daniel mentioned yesterday, we have a tool that is measuring anxiety, and has 7 items. It's called GAD, which in full is generalized anxiety disorder. It is a 7-item a questionnaire that measures the anxiety. So as an analyst or the person pre-processing the data, you want to ensure that you have correctly recorded the anxiety to the correct categories. Usually this is a standard tool, and there are standard ways of analyzing it or recording it. For example, I think in the folder, I can just check in the folder. Where is the folder? In the folder, there's something called PHQ9 or something. I don't know whether you can see it. Let me check. There's a document that has this PHQ9 and GAD7. So let me just share it very fast. I want to share this very fast, and you can. Godswill, you have something to say, please?
Yeah, just a quick one. I was wondering, okay, the recording and the classification that you did using Stata, can't it be done in Excel? Won't it be faster there? Does it matter where you do it?
I'm not sure. I'm not sure if it can be done in Excel. I've not tried, so I'm not so sure about that.
Oh, thank you.
Okay. So this is the GAD7. I hope you can see my screen and it's visible to everyone. So it has these 7 items and these are labels. So 0 is not at all, several days, more than half the days, and this. So for each item, the respondent you'll score the respondent a 0 to a 3 in that range. So there are 7 items. The other thing that is there is PHQ9 that I hope we'll handle some time. But I just wanted to show you how the questionnaire looks like. So these are standard tool. So there are scoring guidelines usually. So you can see here scoring guidelines that this has been shared with you, and you can find it. So you can see what needs to be.
Sorry, Daniel. Sorry, Daniel.
Yes. Yes.
This standard questionnaire you developed, or it's there, you just posted your questions on it?
This is a standard tool. It's a standard. So it's already developed, this one.
Yeah, it's actually developed and validated. It's
Yes.
some of the globally accepted tools. So the PHQ9, they are known. If you actually Google, you'll see some of them are from World Health Organization. Normally, when you are doing mental health studies, you don't want to generate or formulate your own questions, because in the research world, you'll be asked. So we usually use standardized tools to measure these mental health conditions, and there are many. So we have the PHQ9, we have GAD7, and even that, I know even the participants know quite a number of those validated. There are tools that are developed and validated. Yeah.
Thank you so much, Dan and Stanley, for your contributions. So as I was saying, For the scores that you will obtain, we sum all the scores and then categorize them into the categories that we've been shown. So for anyone falling at least under 5, there'll be minimal anxiety. 5 to 9 will be mild, 10 to 14 will be moderate, and 15 to 21 is severe. So the maximum is 21 because we have the highest score is at 3 for each question. And there are 7 questions, so the highest is at 21. And the least score should be a 0 because we have the least score there as a 0 for each question, then that will give you a score of 0. So if I go back to my Stata, having shared that, so you'll see that gives you a background of what I was trying to do. So which questions then are these that I want to sum? So in the data set that you have, the questions labeled A1 to A7 are the ones that are from that tool, and those are the ones that we are going to use to measure the anxiety levels among our participants. So the first thing I do, I generate. Usually this is an extended generation, but you can still use generate. You don't have to use agent. So I generate the score to be a total of A1 to A7. You don't have to do raw total. If you prefer, you can just say A1 plus A2 plus A7, So I've just generated this as a raw total of A1 to A7. So if I run that is what it gives me. And for cleaning purposes, I want to label everything that I generate. So I just label that. I label the variable. Then now I generate the categories. And as I've been directed, I want everyone that is between 0 to 4 to fall in category 0. And I want my category 1 to be 5 to 9, my category 2 to be 10 to 14, and my category 3 to be 15 to 21. So this is what you do. You first generate that category as a blank variable. I've generated that. You can call it anything that you want. And then I say, I want to replace this blank variable to a 0 if the score is between 0 and 4. So the command is, if this score that we have calculated up here is greater or equals to 0, so that just means it's equals to 0, and the score is at most 4, so less or equals to 4. And that is what I do for the different categories. So as you can see that's what happens. So for category 2 is at least 5 to 9. For category 3 is at least 10 to 14. And the last category is 15 to 21. Now, having done that, generated that, I want to say now category 0 is minimal, category 1 is mild, category 2 is moderate, category 3 is severe. And as I've mentioned before, I want to modify so that in case I make any changes, I don't get an error. So that is what I run with this command. And then, so I want to label the categories that I've generated. So you can just run that. And then I want to label the values. I want to label the values that I've generated so that this is readable. And then I want to check how does this look like now. So these are the anxiety level. And this one is an example of an ordinal variable because it has a natural ranking. There are people clearly in this category. There are people in this category. So this is a perfect example of an ordinal variable. So as I mentioned, you can use FRA command to see what each category is represented numerically. So you can just use that and see 0, 1, 2, 3, and there's no missing. So you do that, and then, so that means we have generated our variable for anxiety. Usually, you may want to use your variable as this, or for ease of analysis, you may want to dichotomize this variable. What that means is you just want to have two categories. You want to have a cutoff of, if someone is between 0 and mild, a minimal and mild, then you just say there's no symptoms. If someone is 2 and 3, you want to say that they have anxiety levels. So that really depends on how you want to your analysis to go. So that's what I do here. I want to dichotomize it to that. So I record 0 and 1, I'll say no symptoms, and then categories 2 and 3, those people will be showing symptoms of anxiety. So now that this is what I have. So if someone asks me, among your data set, how many people have shown some levels of anxiety? I'll say 43.41%. So that is how you can set prevalence of something. So that you don't, if someone asks you prevalence, you have to say, 40% are in mild, 40%, 20% are in moderate. So you can just recategorize your age so it's easy for consumption. So I would just say, if I tab anxiety now, this will give me that people who are showing anxiety levels are 43.43%. So that is, you state now, that is now the anxiety prevalence in this population that we are studying. Okay, so having done that, I want to go very fast to the bivariates that we want to do. Where did I type the bivariate? Bivariate analysis. Okay. So I have the variables that we've generated. So yeah. Okay, so I'll set the bivariates here. So where I have already renamed my variables. So for each, this is a loop that you want to do. So you want to check the association between your outcome and each of the variables that is there in your data set, each of the socio-demographic variables. So as Dan showed us yesterday, I just use for each variable of this list, but Dan showed us a local, how to use local. I think you have the do file, you can follow that, but the concept is the same. So I'm just saying for each variable, I want to tabulate anxiety, the categories, and each of those variables. And then, so what I want here is a chi-square because all my variables are categorical. So I'll say column chi, and then the key that that usually populates, I don't want to see that key. So this is a chi-square now test of association between anxiety score and each of these variables. So you just say for each of these variables, tabulate anxiety and each of those variables. I want to see this association using a chi-square test. So this is the command. So if I run this, it's telling me what? Factor variables is not allowed. So there's something that I've done that is not right. So I've done, the error is there. I've said I.var for tabulation. It's not correct. So I've removed that. So this is what it gives me. If I tabulate now, this is what it gives me. So you will actually go and see for each of your variables, it has given you a chi-square, a Pearson correlation, a Pearson chi-square value. So for example, I'll just do just two of them. So for example, this one is sex and anxiety. So you're testing the association between two variables, sex and anxiety, and you're checking is sex related to or associated to anxiety levels. And the result here, you check the p-value, which tells you that it is not associated, given that the p-value is above 5%. So if the p-value is greater than 5%, then there is no association. If the p-value is lower than 5%, then you will say there is an association between sex and anxiety. So for the first variable, which is sex, there is no association given this p-value. Now, Stata will continue to compute for the age variable. And given this p-value, can someone tell us whether the association between age and anxiety levels is significant? In the chat, please, or someone can just unmute and say, is the association between age and anxiety level significant?
Yes, it is highly
Oh,
significant.
thank you. Yeah, so that's significant given that this p-value is lower than 5%. So that is
Yeah.
what happens when you do bivariate analysis. So you're testing one variable, two variables and checking if they're associated. And this is used for two categorical variables. Okay, so now, what if you want to do correlation? And this is just an example. So if you want to do correlation now, correlation, you can only do it for continuous variables. So I want to correlate the score for depression and the score for anxiety and see if there is a significance. So if the command is, this is pairwise, PW core, that is the command, pairwise correlation. So if I run that, variable depression score not found. So that means we have not generated that variable, which should be, I should generate it. Depression score should be generated here. So you'll just follow how I generated that score. It's just the same as anxiety, given the cutoffs. So I want to correlate the score for depression and the score for anxiety. And so if you run that, this is what you find. So this tells us the extent of the strength of the relationship between anxiety and depression. And this is the correlation coefficient. Usually you want to test, is this correlation coefficient significant or not? So that is why I add SIG as an option here, pairwise correlation between this, and then I want to see if it's the significance. So it gives me a significance level, which is down here, 0.000. If I don't want that 0.00 down there, but I just want I just want Stata to show me asterisk if it is significant at any of this level. So for the first one, I do 5% level. For this one, I do 1%. So I just say the command, this is the same command, but now my option is star 0.05. So it will give me an asterisk if that coefficient is significant at 5%. So this is what it shows you. So it shows you that this correlation coefficient is significant at 5%. Some people prefer to use 1%. So I say pairwise correlation at 1%. So it's significant also at 1%. So it really depends with what you're using and what significance level you want to use. Okay. So I know the visualization, we have not touched about it, but you can just check how these values are scattered. You can just check the scatter plot for that, and this is what it gives you. So that is the command. I want to close that. So the command is just scatter the first variable and the second variable. If you want to check add a regression line to see how it's scattered, this is what you do. So as you can see, this is a positive slope. So it means depression and anxiety are positively correlated. There's a positive correlation. And that you can even see from the coefficient. This is a positive correlation. It means as one variable goes up, the other one also goes up. If you have a negative value here, it means as one variable increases, the other one reduces. So the graph shows us, the graph has shown us that the two variables are positively correlated. This is a positive slope, and the coefficient has also confirmed that. And our significance level has confirmed that that correlation is significant. So that is what you do here. The last one that I mentioned was t-test, and I said t-test is for testing the means of two groups. but the means of a continuous variable for two groups. So I want to check if the anxiety score is different by gender. So I just tabulate gender, that is sex, females and males. And then I want to check t-test. I just do t-test the score by the category. So my category is gender, and then my continuous variable is the anxiety score. So that is what I do. When I do that, this is what I see on my screen. So this is the command, and this is what is populated. So from here, you can pick several things, that the observations of males are 162, females are this. The mean score for this is anxiety is 8 among males, 8.7 among females. And this is the standard error, the standard deviation, and the confidence intervals. This is the difference. The difference just takes, the difference is mean for male minus mean for female. So that is what you get here. So this minus that is a negative. And then usually there are three tests that you are shown here. For hypothesis, the first hypothesis is checking, this is one-sided, this one is one-sided, and this one is also one-sided. This one is two-sided hypothesis. So that means this is how the hypothesis is written, that the difference between the means is less than 0. This one, how it is read is that the difference between the means is not equals to 0. The difference between the means is greater than 0. So these two are one-sided, but the one that tells us that it's not equals to 0 is the one in the middle. And the p-value here is 0.3765, which tells us that the difference is, like, there's no difference in the depression score by gender. So that is basically the interpretation. Do we have any questions up to there? I think I'm almost winding up.
Dan.
Yes.
Hi, Dan. Maybe
Yes, yes.
you can repeat the same explanation.
Yes.
Yeah, but in us, even because you have enough time to
Yes.
explain the results for the t-test score, for the t-test. And Godswill has his hand raised. Maybe he can ask before you explain again. Go ahead, Godswill.
Okay. Thank you, Daniel. Sorry for my frequent question.
Okay.
I wanted to ask.
Yes.
These are depression scores. I thought that scores are ordinarily ordinal variables, and as so, we shouldn't be using t-tests and Pearson correlation as we just did. I thought we should be using the non-parametric equivalence of these tests. Just my thinking, scores can be ordinal and not normally distributed most of the times. Depression scores, you get. I thought you'd be doing my Whitney or Spearman's rank correlation. Then I said, let me ask you.
Okay. Thank you for that question. Any other questions?
There is another one by Abebe. What is the difference between correlation and t-test? I know you had already explained, but it's still fine to repeat. The difference between correlation and t-test.
Okay. Any other?
I can't see any other unless, no, there is no other question.
Okay.
Yeah.
Okay, thanks a lot. So I started the last one, the difference between correlation and t-test. So you see, when you're doing correlation, you are checking for the strength of relationship between two continuous variables. So between two continuous variables, you're checking for the strength of the relationship. When you're doing a t-test, you're doing a test of difference of the mean. the mean. You see, when you're doing correlation, it's just you're using the continuous variable as it is, but a t-test will test the difference in the mean of that continuous variable by a group. So for example, or from what you're seeing on your screen, the test that we have done is a test of difference of means. So it's checking if the mean anxiety score for males differs with that mean score for females. But correlation is just checking for the strength of relationship between two variables. I hope that is clear. So for God's will, I said this really is sample data, and I'm just using what variables I have for analysis. So what I was doing is to show you if you want to do a correlation between two continuous variables, then how will you do it, or what will you do, and how will you know that that correlation is significant? There are deeper statistical considerations we need to do, like checking, for example, the way you've said, checking if a variable first is normally distributed. So for example, if I want to check that the depression score is normally distributed, I'll use this, I'll do a histogram of that. And then I think I should add a command for uniform. I should add a command for normal, I think. Normal, yeah. So this is what you see. So from what you can see, it just shows that these scores are normal. There's some scores on the left, some scores on the right, but the majority scores are concentrated on the center. So you can check if your variable is normal with this command that I've just done, and you can do the same for anxiety. For anxiety, you can just check that there's a normal distribution between the scores. And then usually a score is a continuous variable unless you categorize it. For example, age can be continuous, but you can check here. If you check in this case, age here is categorical. So a score is usually continuous variable unless it's categorized. For example, if you have length, weight, those are continuous variables. But in some cases, like in such a case now, it has been categorized. And that is what we mentioned at first, that what is the nature of your variable? Once you have identified the nature of your variable, then how do you want to, given that nature of your variable, how then will you do your analysis? So this is just an example of what you do if you have such a variable in your data set.
Yeah, thank you, Dan. There is no other question.
Okay. Okay, then thank you.
Yeah.
Yeah, so I just said if you are running a t-test, in this data set, we really want to use anxiety and depression as the outcome variable and as categorical variables. So if you have a data set and another data set, you don't have to use anxiety score to do t-test. So this is just an example. It may be a score in a school, maybe math score, English score, literacy score. You may want to check that by gender or anything, or the weight or BMI or something like that, So that's why I was doing t-test, because these are the only, I can say, the only continuous variables I have in this data set. They got the anxiety score and the depression score. So if I run this is the command t-test and then the continuous variable, and then you say by and then the group. So let me check if there's another group we can use for the age. Okay, those ones we'll use for one way ANOVA. Okay, so if I do t-test by gender, my screen is small, so I need to increase that screen so that, okay, so this is what you get. And this, as I've said, how you interpret this is males, this is the number of observations in the second column, first column. These are the means, and it represents mean of what? Mean of the score that I've been trying to do. This is the anxiety score. So these are the means of the anxiety score for each category. So it means males scored a mean of 8.1 in anxiety, and females scored this. That is the mean. And this is the standard errors. This is the standard deviation. This is the confidence intervals. Now combined, it means both males and females, or in the entire data set, we have 334 observations, and the mean score for anxiety for the entire population is 8.4. And these are the other statistics. Now, when you come to difference, the difference is defined below. It tells you what does this value mean? It means that it's the difference of the mean for males subtracted the mean for females. So actually now our test is checking if this difference is significant or not. So this actually is the value that is being tested, if it is significant or not. So you can see this hypothesis here. This hypothesis checks that this difference, is it different from 0 or not? So I've mentioned that this one is a one-tailed test, checks if the difference is less than 0. And this is another one-tailed test, checks that the difference is greater than 0. But now we're usually interested in this, that the difference is not equal to 0. And the p-value here, if it is less than 5%, it indicates that the difference is not equals to 0. So like we usually say, if the p-value is less than 0.05, we reject the null hypothesis. But in this case, it is greater than 0.05. So we do not have enough evidence to reject this hypothesis. And our conclusion would be that the difference between the means of the males and females is not different from 0. Daniel, do you want to add something on that?
Sorry, Dan. I think
Do you
you've.
want? Okay.
There is anything? Can you hear me? Hello.
Yes, we can hear you, Dan.
Oh yeah, I think you've explained it well, Dan.
Okay.
Yeah, because I wanted you to reiterate the issue of hypothesis testing, because I know people are exposed to that, but they don't know how to go about it. So thank you.
All right.
Yeah.
All right, then in case there are any questions, please drop in the chat. And as I do the last bit of this, now I'm going back to, yes.
How do
I can't hear Stanley. Can someone hear?
You are breaking. Stanley, you are breaking.
Stanley, please put your question on the chat.
Yeah, because you can't hear him.
We can't hear you. All right, so, okay then. So if we move on.
You explain correlation to T?
Stanley, you can just put your question on the chat so that we'll respond to you, please. I hope that's okay. All right, so our interest today was to check for anxiety. And usually from the bivariate analysis, maybe a variable is strongly related or associated with your outcome. But A variable does not live in a vacuum or does not exist in a vacuum. There are several factors that contribute to a person's mood, feelings, or now in entirety, whether they can experience anxiety or not. And that's why we usually work with the multivariate analysis. Now, what does multivariate analysis do? Multivariate analysis combines all the factors we think could contribute to an outcome, and then we put them together in a model. Once we put them together in a model to check if in the presence of other factors, can a variable have a significant effect on our outcome? What I mean is, if you have, for example, if you have an outcome for student performance, and you want to check what variables are
Daniel,
associated.
I asked.
Please, Stanley, please put your question on the chat, please.
Daniel, please.
Yes, you can hear you now.
I asked, what is the difference?
What is what? What is the difference? Or Stanley, we can't get you. Come up again. Or did somebody hear what Stanley is asking?
Okay.
Please
Stanley,
type.
please put your question on the chat.
Yeah. Type on the chat, we'll respond.
All right. So as I was saying, I was explaining why we do multivariate and how it's different from bivariate. So we've mentioned bivariate is testing the association between two variables. But now, as I've mentioned, that a variable does not live in a vacuum or does not exist in a vacuum, and you want to check, there are several variables that contribute to an outcome. We usually call these variables predictors. In more clinical terms, they are called covariates. Some people like to call them independent variables. So as I was giving an example of student performance, you want to check which variables are related to student performance. And maybe you have a variable like age, and then you check, is age related to student performance? And then you find that it is related. So you cannot immediately conclude that performance depends on a student's age unless you consider other factors like maybe location or household wealth index or some things that other factors that you think will contribute to an outcome. So now there are many ways of doing a multivariate analysis. We are not going to the depth of it. Because your analysis actually depends on your outcome. What is the nature of your outcome? If your outcome is continuous variable, there's a analysis to carry out if your outcome is continuous. The analysis to carry out if your outcome is continuous is not the same as the analysis to carry out if your outcome is categorical. So some people would prefer to do multivariate linear regression if their outcome is continuous. If your outcome is categorical, you may want to do a multinomial logistic regression, or you may want to do multinomial ordinal logistic regression. So they're different. So that's why it's important to know what type of variable you are handling and what type of analysis then you can do to correctly respond to your objectives. So for today, we have our variable called anxiety. It was GAD, so it's anxiety category. I'm just typing it here so that we see how it looks like. So this variable here, it takes a 0 if someone has shown no signs of anxiety and a 1 otherwise. So our variable is a binary variable. So for binary outcomes, we're going to use logistic regression. For binary outcomes, we're going to use logistic regression. And I have mentioned the importance of knowing what is the nature of your variables, and you will see them how we input them in our model. So the command for logistic regression is just logistic, and then the outcome. So I'll just put here, I can just put the command in. It's just logistic. And then you'll have your outcome variable. And then you'll have your the independent variables. The independent variables. And then if you want the odds ratio, you can specify as OR. So that is what I do here. So if I run this command, what does it give me? My window is small, so I'll just increase it. My window is small, so I'll just increase the window to that. So this is the result that I get. There's a lot to interpret here, but interpretation, you can be interpreting a wrong thing. So it's usually important that you fit in the correct model. That is really the important step, that the model you have fitted is the correct one. So that when you're coming to interpret, you're not interpreting a wrong model. Now, this table is a table of logistic regression for anxiety and the socio-demographic variables. Someone can be asking, why am I putting I dot here? For every categorical variable, you use I dot before that categorical variable because they have categories. So that you can see here, so that the Stata understands that we are inserting these variables as categories and not as a single category. So you will see that, okay, that's the reason why we use I dot for this case. And the option for OR will give us an odds ratio for interpretation. All right, so to interpretation, we have, it tells you this is a logistic regression. The number of variables that have been used for this analysis is 334. And that means that there is no missing values in this data set. If there was any missing values, perhaps in gender, then maybe 2 values, then this will have reduced by 2 because the analysis is only carried out on completed instances. So this gives us the significance level of the model. It tells you, can your model accurately give you, answer your objectives? Is this a significant fitted model? Is your model significant? So that is what this does. Okay. So these are the important things to check. Is your model significant, and are all your observations incorporated in your model? If not, that it means there are some variables that are missing observations. So,
sorry, Daniel, to take you back. What is this you keep on saying model?
okay. All right. Okay. So a model is so if you are doing like a regression, then you have a dependent variable and independent variable. Usually in statistics, we put them in an equation and call that equation a model.
Okay.
Yeah.
Before you continue further,
Yes.
you are using a vocabulary to explain another vocabulary, regression.
Can someone hear Stanley?
He's complaining that we are using a lot of vocabularies.
Okay.
But then maybe go ahead. And
yes.
For me, I think I would say, Stanley, there are some, will I say, there are words that are used in different contexts. So like, looking at the world model in statistics, that's a word that you'll always come across. It's a phenomenon. It's a representation of the whole. Actually, I was also looking at a simpler definition, and maybe I can read for us. And then I'll allow God's will. Is it God's will? God's will to also say something, to weigh in on that. So in statistics, a mathematical model it's actually, I think the best word to use is it's a representation of
Okay.
a phenomenon. Yeah. Maybe go ahead, Godswill.
Okay. I just wanted to throw in more light. I think a model is a mathematical.
Can someone hear Daniel?
Hello.
Yeah, well, Godswill is
Yes, we
one
can
who
hear
is
you, please.
speaking. Daniel,
Okay.
we can hear you. Stanley, can you hear the responses that are coming from the participants? Chisom is trying to explain the word
Okay.
model. Yeah. Go
Okay.
ahead, Chisom.
Okay, thank you so much. I think to make it very simple, a model is a mathematical equation or yes, an equation to explain how two variables interact. Are they related? At what level are they related? Can one predict the other? That's just a model. So when you do that, you actually you are building a model such that you can apply that to another variable if all things are equal. That's a model. So if your outcome
Yes.
variable is
Thank you.
Yeah, it's like a formula, Stanley.
yeah,
It's
yeah.
just like a formula, something that a way of doing
Thank
something.
Thank
Yeah.
you.
Thank you
All
so
right.
much, Godswill.
Thank you.
Thank
Daniel,
you. Thank you. Thank you
Daniel,
so
please,
much.
Okay.
Okay. Okay. Thanks. Can I allow Daniel Miner, you can explain the regression model, the logistic regression model, just the output, if you're there. I think my internet is. Dan, can you hear me?
Oh, hello, Daniel. I can hear you clearly.
Oh, okay.
I've
My
sent you a
internet is
message.
buffering.
Oh, it's buffering, although we can hear you clearly.
Okay.
Yeah, although you had already explained
Yes.
the different statistics, the different statistics that, or rather the outputs that we get from this model, including the number of observations. I think you had already explained that.
Yes.
Yeah.
Okay.
However, if
Oh,
you want me to go ahead and explain. Hello,
yeah, I think,
Daniel.
yes, I think we can like explain, for example, what
Yeah.
like, for example, this one, what these numbers mean, like, in terms of interpretation. How do we interpret this, maybe just the odds ratio, I think, and the significance level. Those are the main things. Yeah.
Oh, yeah, sure. So the first statistics that, or rather the first result that we get up there. Okay, you've already talked about the number of observations.
Yeah.
Then we've also talked about the chi. Did you explain anything to do with the chi-square test? It actually gives us the overall significance of the
Yes.
logistic regression model, the probability associated with these statistics. Yeah, and it also indicates whether the model is statistically significant, especially if the number is, if it's actually lower or lesser than 0.05. Yeah, that one actually tells us whether the predictor variables collectively, all of them in combination, have a significant effect on your variables. Yeah, so like in our case, it shows that in combination, all these variables are actually statistically significant, because when you look at that value, the 0.000, of course, that one is lesser than 0.05, which is a standard figure that is used. The other thing that you look at is the pseudo R2, which actually indicates the proportion of variance explained by the model. Yeah. And remember, the values that we are getting up here with the four, or rather the 4 items, this one is actually looking at the overall output from your model. Then the other things that you look at are the coefficients for each predictor variable, and the predictors are actually in our example we have sex, then we have age, and for each of them you can actually see that we have different responses. Looking at the year of study, you can see that we have quite a number of levels. So for each predictor, the output provides the following information. One, we have the odds ratio, and which represents the change in odds of being of actually that predictor variable. Then we also have the standard error, then the statistical significance, that's under that is the P. You can see the P value, which is column number 1, 2, 3, 4. Yeah, that one also actually gives us the statistical significance of each variable. Up there, we had the overall statistical significance statistic, but down here we actually get per each variable. So what else is important there? Maybe the constants. Dan, can you give us an explanation of the constants? Hello?
Listen.
Hello?
You can hear me?
Yeah, and before maybe you proceed, let's hear
Yes.
what God's will. I don't know whether it's a question.
Okay.
God's will. Yeah.
All
Thank you,
right.
Dan.
Okay. Can I speak?
Yes, please.
All right. I wanted to ask a quick one before you explain the odds ratio and what they mean. How are you able to code the reference categories? Let's say, for example, in the age, you had 4 age groups. Please, can you go up a bit? Sorry. Just go up a bit. All right. Yeah, in the age, you had 4 age groups. So I believe that should be the first one that should be the reference category. How did you code it? Did you code it as 0? The way you coded the output variable as 0 and 1, do you get like the sex, the male that is the reference category? Do you code it as 0 or do you say 1, 2?
Great.
And then there are
great question.
and then there are some times when you do this logistic equations, Stata will say 1, odds ratio of 1, and say omitted in the standard error for some categories. Why does that happen?
Okay. That's a great question. I will attempt to answer you. When you do logistic regression, the lowest value becomes your reference. And that's why when we were doing the recording, when they do it, for example, for gender, when we were explaining what category do you want to be 0, which one do you want to be 1? So Stata will automatically classify males as the reference category because they have the lowest value here. So for year of study, I can see year 1 has been put as the reference because it has this. It's the lowest. It takes the lowest value as the reference. I don't know, Daniel, if there's another reason, but that is what I understand, that Stata automatically picks the lowest value as your reference. So when you're interpreting this, you will interpret the odds ratio relative to the reference category.
Yeah, very true, Dan.
All right. And then the question on the question on omitted. Usually I have experienced the same, and thanks for highlighting that. I've experienced the same, but it's usually in a case where one category has, for example, if you ask people, have you ever attended school? And 99% say yes, and then 1% just say no. Usually I see such a variable in my model, it indicates 1 in the odds ratio, and then in brackets omitted. So I don't know the exact reason, but it's usually with the variable that there's a very big difference between responses. If there are 2 responses and there's one that a majority, almost all respondents is the same. So I think that is why it gives you that omitted, because almost all respondents is the same. And another thing you can observe in this model is collinearity. If a variable is related to another one, that means it's a multiple of another one, or Stata detects some collinearity. We can check up on that when we break. It will drop that variable, the variables that are collinear. Or you'll get an error that tells you that this variable predicts the outcome perfectly. So then in the model, that such kind of a variable will be dropped. But it's a case-by-case basis. So when you get such an error, you just check up what does that error mean.
Okay. Done.
Yes, there's someone else speaking.
Yes, that's Stanley. Please go ahead, Stanley.
Done. Yes, it's me.
Yes, Stanley.
What am I to the one of the make? There are two variables, fair and good. Are you seeing? Academics. Okay. Fair and
yeah.
good. Are you seeing that?
Yes.
Yeah.
So if after generation, then the starter generated those numbers. How do you discuss these numbers on your results? Like the first
Exactly.
one here, like fair is 1.33, good is minus 711. How do you discuss those digits that have been generated there by Stata?
Very well. Very good question. Stanley, thank you very much. So we can start even from here. Daniel was explaining these numbers. So this odds ratio, there's usually there are usually different ways of explaining the odds ratio. And the criterion is usually to check if the odds ratio is greater than 1 or less than 1. If the odds ratio is greater than 1, for example, here, then we are saying that females have 1.17 higher odds of having anxiety symptoms compared to our reference group, which is male. So when the odds ratio is above 1, we're talking of higher odds. Alternatively, you can talk of females are like this is like it looks like it's 17% higher odds of more likely. You can talk of more likely and not odds now. You can say now females are 17% more likely to exhibit anxiety symptoms compared to males. So there are two ways. You can either interpret them as odds or as a likelihood. So just repeating, so if it's greater than 1, for example, in this case, we know our reference group is the male. So we are going to say that females have 1.17 higher odds of exhibiting anxiety compared to male students. Alternatively, you can say that females are 17% more likely to exhibit anxiety compared to males. So how do you get 17% from this number? This is usually we say this number minus 1. 1 is usually the standard. So this is 1.174, and these are the numbers. You can ignore the decimals. The rest of it, but you can always round this to 2 decimal places and use those 2 decimal places as a percentage. For example, this would be 65% more likely. This will be now, if it's now 2.3, you don't want to say this is now 130 more likely. If it's greater than now
Just
2.
to take you back, so in your discussion,
Yeah.
Thank you for your explanation. I think it has come out on the discussion well. I just want to, if I have understood it well, you put into 3 things there. The anxiety and the gender plus the
Yes.
odd ratio, correct?
Yes, correct, yes.
To try to discuss.
Mm-hmm.
Okay, to try to discuss.
Yeah.
So just clarify to me, anxiety, sex, female, sex and female to be, anxiety to be, which are the variables out of those three?
Okay. So, as I mentioned, when you run your regression, the first variable here is your outcome. So when you say logistic anxiety, anxiety now is your outcome or your dependent variable. So everything else will be like we are checking on how the different independent variables or predictors contribute to anxiety. So in the at the onset, you know that anxiety is your outcome. So everything we are trying to do here is checking of how now gender is related to anxiety. How age is related to anxiety. You can see at the top here, the outcome variable has been indicated. The outcome variable is anxiety. So everything you do is interpreted in terms of our outcome variable. Yes.
Can I add something, Dan?
Please, yes, do.
Yeah, most of these things, Stanley, are determined by research that has already been done. Actually, it's not something that you just feed in. You don't just do logistic regression and you have your out. Of course, for example, this study, they were actually looking at anxiety, and they were also looking at other outcomes of interest. But even as you do that, even before the data is collected, people have at the back of their minds that there are different things that contribute to this. Maybe income level, employment, maybe gender. Sometimes you may find that maybe females are usually more prone to anxiety than male. So definitely that tells you that gender also contributes to anxiety. So that's why I think when Daniel was beginning to talk about this kind of analysis, you have your outcome of interest. In this case, it's anxiety, and it's categorized in this case. And then you bring in all those other predictors or all those other factors that you know usually influence anxiety. And now you now want to, based on the output that you'll get, you want to see how does gender contribute to anxiety? How does the age of a person, either whether it is in form of category or when you are looking at data for a university, do we have first years more prone to anxiety, or fourth year, or people who are in year 6? That's why you are seeing the year of study. Then you can also go and look at academic performance. People who perform well, are they more prone to be anxious? Yeah, so that's why I think I wanted to respond to you. How does all these things come into play in this result? Yeah, so we have the predictors. Predictors are what Dan is showing us on the left-hand side. But at the beginning, at the top of that column, we have the outcome, our variable, or rather our outcome variable, which is anxiety. Then we compare it with all these other things. Thank you. Over to you, Dan.
Thank you so much.
Thank you. Sorry, guys, if I'm to ask this general question. I'm enjoying this presentation and it is quite helpful for all of us scientists. I wish I could have been able to log it to my Python. I don't know why I'm getting trouble, and that's what I want to use to do some science straight away, because access to this software is a problem to me. Who can help? Because the link someone has posted here I've opened, but it tells me to sign, and I can't access what is going on there. Yet I have the Python on my desktop. Anyone who can help can reach me even on my email. I'm there, and I can even write my telephone number for WhatsApp communication, although my phone has an issue for now, but maybe tomorrow it will be okay, to help me to move.
All right, Stanley. Thank you so much. So anyone who can assist Stanley, you can reach him on the chat, please. And yeah, as we mentioned, the Stata software is commercialized. So you have to, if you don't get one, you have to purchase. If you can purchase one, then maybe your organization can assist you with one. So we were explaining this output that is here, and someone correctly asked about the reference. There's usually a reference group, and the reference group is usually the one with the lowest value when you are doing your categories. So for example, in gender, it will be males will be our reference group. It is coded 0. Age 18 to 22 years will be our reference category. So what do we mean by reference category is what you will be explaining in relation to when you are explaining now your results. So for example, we have explained this one. So we are saying compared to males. So you're saying compared to males, females have a 1.17 higher odds of being prone to anxiety. So always you have to refer to that reference category when you're interpreting the odds ratio. But you can also, the important thing is to check if the odds ratio here is significant or not. So you can see even if it is true that females are 17% more likely to develop anxiety than males, that percentage is not significant. You can check here on this column written P value. So those two, you check that, and yeah, I think there's one that is below 1% that I would also like to interpret before I just hand over back to the organizer. So for example, here, you can see mental health. So mental difficulty. So how do we interpret this? I will say that this is about 3 times. 2.7 is about 3 times. So students who have mental difficulties are about 3 times more likely to develop anxiety compared to those who do not have mental difficulties. Or you can just say that students with mental difficulties have 2.77 higher odds of being prone to anxiety compared to those who do not have mental difficulties. And the p-value here, is this less than 0.05? Yes, this should be less than 0.05, I suppose. So that is how you interpret. There's one that is less than, I want to interpret this, the last one here. So quality of life, if you want to check quality of life, just want to check what is the reference category. So the reference category is low. So I want to interpret this result in reference to low. So you interpret those students with average quality of life in reference or in comparison to those with low quality of life. So we say that those students who have average quality of life have 0.62 lower odds. So this is lower because it's less than 1. So you say lower odds of exhibiting anxiety compared to those with low quality of life. And then those with high quality of life have 0.45 lower odds of exhibiting anxiety compared to those with low quality of life. So when you're interpreting this, you interpret average versus low, and then you interpret high versus low. So those two versus now our reference category. I know maybe some things are not so clear, but in case there's any questions, you can respond. Dan, I would wish to stop there and maybe hand over to you if you have anything, or back to Muluse. Thank you so much.
Wow, thank you so much, Daniel. That was I think that was a handful. There is so much that you've trained us on. Thank you, Gloria. I think we can clap. You can use are they the reactions to clap for our facilitator today. You've really taught very many things, very many things. And I bet the participants can also attest to that. So my challenge to all of us is, don't think that you've learned until you do it yourself. We will share all those do files and all the material we've been using so far, so that at least you can use it as a reference. Go back, try to run a command at a time, a command at a time, a command at a time, and then try to see whether you understand. Does it really make sense? You can even use a very different data set if you have. We have, you can actually access data sets online that that were collected for mental health and try to actually do the same analysis. So you can run, you don't have to do everything, but at least do step by step, so that by the time we get into tomorrow's session, come back with questions. Whatever was not clear, if you did something and it didn't work on your end, you can actually come back with it and tell us, you know what, this is what I tried to do. I don't know whether it makes sense. Was I doing it the right way? So that at least at the end of the day, you'll have understood. So practice, 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 practice makes perfect. Implement what you've learned so far. I also want to take back the session to Muluse. Muluse. I know
Thank you.
Welcome. Yeah.
Okay. Thank you, Danny. Thank you, Daniel. Osuka. It's really very informative and a nice session that we had today. And I hope our participants also appreciate that. Tomorrow we will continue on the remaining topic. We know that 3 days is not enough. We know that learning software through webinar is not also easy, but we do feel that we contribute a thing or two things. Like I hope you learned a thing or two things from this session. So I really appreciate Daniel for this, giving us his time, and I really appreciate his commitment. So thank you very much. Thank you for attending the session. I wish you all best. Have a nice good evening for East African team, and good afternoon for our West African family. Bye-bye.
Thank you. Bye-bye, everyone.
Bye-bye.
Bye.